Hi, I am Bhavagna. In this video, I'm going to tell about the project we worked on. The domain we chose is healthcare data. Our main focus was to transform that raw data into structured and clean formatted data through ETL process. Before we are getting into the transformations part, first we need to understand clearly about the data set, like how many tables are in the data set, how they are interconnected with the each other, each tables. Now we have five main tables here: encounters, organizations, patients, payers, and procedures. In encounters table, we'll have the details of the particular visits to that hospital. Like that patient is visited once to that hospital, that record will be stored in this encounter table with encounter ID, all these primary keys and description like what is the problem, why did he visit that particular hospital. All these things will be in this encounter table. Next, we'll have organization table. In this organization table, there is only single record. That means this entire data belongs to only single hospital. That is not the main table here. And next, patient table. In this patient table, we'll have details about the patients like name of the patient, age, gender, and address of the patient, phone number, everything related to that particular patient. And next, we have pairs table. In this table tells about which who paid for the treatment. Like for example, we have an insurance company, health insurance company. It will give X percentage of coverage to the particular patient. Through the company, they can pay bill, or some patients won't have that insurance, so they will do self payments by that particular patient only. So this is all related to that particular payments stuff. Next, procedures table. Procedures means when the patient is visited to that hospital, what are the procedures he underwent? Like doctor suggested him to take blood test and scan. So these are the procedures he took on that particular day. All these procedures will be recorded in this procedure table. Now here is the main challenge. In this data set, the tables are interconnected with each other. One patient can have multiple encounters, like one patient can visit the hospital multiple times based upon the seriousness of his condition, and one visit can lead to multiple procedures. Like one time the patient is visited to that hospital and the doctor said him to take blood test as well as MRI and X-ray. So he leads to three procedures here. So one patient can have multiple procedures and one patient can have multiple encounters also. This creates one to many relationship, which means we cannot directly analyze this data like sample data. Because of this structure, if we directly combine these tables together, we may end up with creating duplicated values and incorrect results sometimes. So now we clearly understood about this data set. The next question is, how do we transform this complex data into like clean and structured data that is usable for analytics purposes? In the next part, we'll look into this data set, how this transformation is achieved using Medallion architecture.
We build a medallion architecture for our hospital management data pipeline. Our objective is to ingest raw CSV data and store it in the Delta format and clean and standardize the data for business analytics data ready. So we have five raw sources here: encounters, organization, patients, payers, and procedures, which were actually in the CSV format. In the bronze layer, we ingest the raw data and store them in the format of delta. So we can see the actual here. It consists of null values and duplicates. See, these are all the tables that we are using in our project. This is related to the bronze layer. Why we use bronze layer? Bronze layer because it converts data into delta formats and we process the original data for auditable and recovery. And now let us go to the silver layer. In this silver layer, we perform transformations like removing duplicates, fixing column names, handle null values, and perform business transformations. Silver layer improves data quality and prepares it for analytics. At first, here we had loaded the data from bronze layer into the silver layer, which is actually in the delta format, and we perform the transformations like dropping the duplicate columns in every here in encounters table ID, the column name ID, which acts as a primary column, which has unique ID name for each and every row. We are duplicating the ID column so that no all the records will be unique. Same we are performing in the patients table also, dropping the duplicates. And again, we perform with column renamed operation to change the column names for business analytical readable format. See, we change the uppercase letters into lowercase and also removed unwanted spaces and specifying the column name clearly. And here we converted the start time and end time into a timestamp dates. So here we converted its type, and also we dropped the null values in some specific columns like encounter ID, patient ID, and start time. And we also filled the null values with -1 and unknown. See, after handling the null values and dropping the duplicates, our data looks like this. There are no null values, and the null values were replaced with -1 and unknown. Same operations were performed for all the four tables which we are considered. See, at last, the main theme of this silver layer is creating a fact table which is useful for business analytics. Here, I performed inner join and joined the encounters table, patients table, pairs table, and procedures table, and created a unique fact table which contains the important columns information. Here it contains encounter ID, pair ID, patient ID, start time, end time, organization ID, and all the required columns. After this, we had loaded back the data into the silver layer in the format of delta. And then coming to the gold layer, we again load the gold data from silver layer into the gold layer in the format of delta for performing the business analytics. This will be now we can see that see those analysis in the next part.
My name is Swaraj, and today I'm going to explain about the KPIs, which is key performance indicators. So this will help us to get into the all business insights that we are performing on the raw data, which was passed through the three layers of a medallion architecture, which are bronze layer, silver layer, and gold layer. And in gold layer, the data is very useful for the business purposes, and which is an aggregated data. So now I will get you through the KPIs. So here we imported and we created a session, PySpark session. So here and next we imported the silver data. In the data are encounters, patients, payers, and procedures. And next we here loaded the fact table, which is in the format of an delta format. And we displayed here, we can see the columns of an encounter ID, pair ID, all IDs related to all other tables. And here this is a full name. We are concatenating the first name and the last name to get a full name. And next it is an we are dropping redundant columns from the first name, last name. And next here we are from the fact table we are dropping an additional address column where it contains a city, country, state, latitude and then longitude columns. And here we are adding an age by the start time and the birth date. we are using the formula of start time minus birth rate so that we can get an age of a patient. And next year, in a fact table, we are adding a column when death date is null, it is deceased, otherwise alive. So we are finding out whether a patient is deceased or alive. And now we are displaying it on a table. And again, we are writing it to an gold, which is an aggregated data, and we are saving it as an gold fact df. And now we are going to perform an KPIs here. So these are the APIs that are developed. So here it calculates an encounter duration. It converts start and end time into hours and helps measure how long each hospital visit lasted. And next it computes the financial efficiency. It percentage covered by payer and shows how much cost is recovered versus how much is billed. And next is it calculates an patient burden, that is an amount patient pays useful for affordability analysis. And next it calculates the care intensity, that is the cost per hour and the procedure intensity score. So this still transforms raw data into meaningful KPIs like cost efficiency and duration and patient financial burden. And next comes an age-based cost segmentation. Here it creates an age groups, segments patients into six categories, pediatric to elderly based on the age here, and then it aggregates the key metrics, total encounters, a unique patterns, average cost per encounter, and it also calculates a mortality rate, that is the percent of deceased patients in each group, and then it derives an cost insights about the cell. And next this KPI is about an high-risk patient identification. So it is identifies the high-risk patients based on the risky score or many encounters or high lifetime spending, and select important patient details, includes demographics, revenue procedures, and it also assigns an priority levels based on a risk score. So this will identifies the high risk patients and prioritizes them for better healthcare management. Overall, these cells convert raw healthcare data into actionable insights for financial analysis and population health and patient risk management.